And yeah, today I'm going to talk about between-person differences in sensation seeking and what those differences might mean for brain-based models of adolescent risk-taking. So just to start with some acknowledgments, I did this work as a PhD student at Penn State with Chuck Geyer and using some data from Bea Luna's lab at the University of Pittsburgh. And I'm currently a postdoc at the University of Pennsylvania with Danny Bassett, and I'm going to talk a little bit about my new work today. So I'm generally interested in risk-taking during adolescence. I'm going to just broadly define this as engaging in behaviors that are high in subjective desirability, but that also carry potential for negative or maladaptive consequences. I'm really interested in cigarette smoking. This has positive aspects in the short term. Some people feel like it gives them a buzz or it can be relaxing, but of course it has negative consequences. In the short term, it might be associated with an odor. In the longer term, we know there are all these health problems that might come along with being a smoker. If we look at cigarette smoking during adolescence, you can start to see why I think this is a particularly interesting time to be studying risk-taking. Here, what you see on the y-axis is smoking initiation probability. On the x-axis, you have age. We typically define adolescence as between 13 and 17 years of age, but I can talk more about that age range because there's no concrete end or concrete start point to adolescence. Each line here is the smoking initiation probability across age, across different birth cohorts. And even though you can see a lot of differences in terms of the magnitude of smoking initiation across these birth cohorts, there's a kind of similar inverted U-shaped curve going on where the peak is during adolescence. So you see this rise in smoking initiation at the start of adolescence, highest probability of smoking initiation occurring during adolescence, and then decreasing. You see this inverted U-shaped curve all over the adolescent risk-taking literature. You see it for substances beyond cigarettes, and you also see it in laboratory tasks where we try to look at developmental differences in risk-taking. And so there are going to be a lot of things that factor into what leads to this inverted U-shaped curve and the importance of risk-taking during adolescence. But one thing that I've been particularly interested in looking at are brain-based models of adolescent risk-taking.
So in previous
Sure.
So over time, the variance has changed, right?
Yeah, so you see differences in like the amount of people that are smoking, right, across different both cohorts. But you can see that the peak tends to generally coincide with what we think of as adolescence, regardless of the broader changes that are happening throughout these different birth cohorts. So with these brain-based accounts of adolescent risk-taking, they highlight this mismatch in the timing of the development of subcortical limbic structures that are involved in incentive processing, that are involved in generating approach motivation to get rewards. So these are the subcortical limbic regions. And then a mismatch between that development and the development of regions of the prefrontal cortex that are involved in inhibiting impulses to approach, and more general functions that are involved in flexibly modifying our behavior to get at our goals. And so this is kind of shown in this figure by Casey from 2008, where you have age on the x-axis, and she's highlighting where adolescence is happening. And we're looking at the functional development of the prefrontal cortex in gray, and you can see that there's this kind of protracted, like almost linear development of the prefrontal cortex, where its functioning is becoming better and better, kind of steadily from childhood into adolescence into adulthood. And then in contrast to this, you have the development of the nucleus accumbens, a core region in this kind of incentive processing system, where you see this kind of sharp increase in its functioning when you get to adolescence, and then a more milder graduation, maturation of this region in contrast to this prefrontal cortex. And so what this kind of mismatch means, where you have the biggest gap in the functional development of the nucleus accumbens and the prefrontal cortex, is kind of put forward nicely by Steinberg, where you have the functioning of the cognitive control system associated with the prefrontal cortex. It's increasing gradually, so we're gradually getting better and better at inhibiting our impulses. But adolescence is a peak for the functioning of the socio-emotional system, so the system that's involved in generating impulses to approach reward. And so we have heightened motivation to approach rewards, very high inclinations towards sensation seeking, so seeking out exciting and novel and intense experiences in the context of this immature or weaker cognitive control. And so risk-taking from this perspective and engaging in things like cigarette smoking is viewed as a self-control failure. We're not able to inhibit our impulses to seek out these novel and exciting experiences. There's been a lot of work on these models. I'm not going to go into all that research. I'm just going to focus on a couple of critiques that have been raised that kind of were the basis for the studies that I did during my PhD. So one is that most adolescents don't engage in substance use. These models are normative models of adolescent development and risk-taking. Can they accommodate these between-person differences? So we see about 20% or fewer adolescents engaging in things like cigarette smoking. And this has led to this extreme perspective by people like Bjork. He has some really nice work on this, where that it's probably just a subset of adolescents who have this a sufficiently extreme imbalance between the functioning of these two systems that could meaningfully impact risk-taking. The second critique is this emphasis on self-control failures in explaining risk-taking. We know that decisions to engage in risky behaviors can be based on deliberation and not just impulsiveness. And so I'm going to talk about that a little bit. And then finally, while these mechanisms may be plausible, I kind of wanted to get at the ecological validity of these mechanisms and to see if this is actually what is happening in daily life. So in terms of the studies, the first study is going to ask who are these risk-taking adolescents, and it's going to look at between-person differences in sensation-seeking and how they relate to cigarette smoking during adolescence. The second will look at impulse control in sensation seekers. We're going to look at network neuroscience correlates of impulse control, and then we're also going to look at levels of impulse control in the daily lives of sensation seekers to see if they are demonstrating this difficulty in impulse control, and if that might be a mechanism through which they're engaging in substance use. And finally, we're going to look at pathways to risk-taking beyond self-control failure. Okay, so for the first study, in terms of who are these risk-taking adolescents, again, most adolescents don't engage in drug use. And when we look at the functioning of the socio-emotional system, you can't really see that there, but so this dotted black line, even though it has a normative peak during adolescence, age accounts for a modest proportion of the variance in the functioning of these systems. So this is a figure from work by Glea Somerville, where she has children, adolescents in gray, and adults in white again. And it's looking at the nucleus accumbens response. So again, this region that's at the core of this incentive processing system in response to appetitive or rewarding cues. And you can see that adolescents as a group have a general increased response relative to children and adolescents, but you can see that, or adults, but you can see that many adolescents are just like the children and just like the adults. And so this has led to the perspective that maybe it's a subset of adolescents for whom this imbalance between this socio-emotional incentive processing system and cognitive control system is sufficiently extreme to affect their risk-taking. So for this paper, I looked at age-varying associations between sensation-seeking and smoking to get at this. It looked at the importance of between-person differences and sensation-seeking during a time of normatively heightened risk. And just to give you a little bit more background on sensation-seeking, this is a tendency to seek varied, novel, intense sensations and experiences. It's associated with the functioning of the incentive processing system. So people who are high in sensation-seeking tend to show exaggerated responses in the ventral striatum and other regions of the incentive processing system when they're exposed to rewarding cues. It's a predictor of smoking, generally, and we also know that sensation-seeking peaks during adolescence. Okay, so we can kind of hypothesize that people who are high in sensation-seeking will be more vulnerable to cigarette smoking, but we can go a little bit further and think about adolescence specifically, and that adolescence is this confluence of a range of biopsychosocial vulnerabilities. So not only will people people high in sensation during sensation-seeking be at risk for engaging in cigarette smoking, the people who are high in sensation-seeking during adolescence are going to be especially high in sensation-seeking relative to anyone else in your sample, since it's a time of normatively heightened sensation-seeking. So they're going to have these greater impulses, and that you would expect that to lead to a greater association between sensation-seeking and smoking. It's a time of immaturities in cognitive control. So again, while adults who are high in sensation-seeking may want to seek out novel experiences, they're going to have more accurate cognitive control, greater abilities to inhibit this approach motivation, and so we would expect there to be a lower association between sensation-seeking and cigarette smoking at that point in the lifespan. As you move into adolescence, you see decreases in parental monitoring. So now tendencies such as sensation-seeking will have the capacity to express themselves in a way that they weren't able to during childhood. And again, another kind of component is the idea that cigarettes are still illegal during adolescence. And so that illegality of cigarette smoking would be a source of stimulation for people who are high in sensation seeking, who want these novel, intense experiences. And so based on all these things, we hypothesized that this would render the association between cigarette smoking and sensation seeking strongest during adolescence. So we refine our hypothesis and we say that adolescents who are high in sensation seeking will be the most vulnerable to engaging in cigarette smoking. To test this, I used waves 2, 3, and 4. These were the waves. There are 5 waves in total now, I think. But these are the waves where the items of interest were available. This was a national longitudinal study of adolescent to adult health. It's publicly available for anyone to use. About 5,000 participants, some repeated measurements, and then age range from about 13 to 34. Sensation seeking was measured with one item. It was, I like to take this risks, so getting at this kind of having impulses to do exciting and novel things, going from strongly disagree to strongly agree from 1 to 5. They were asked about their cigarette smoking in the past 30 days, and we created 2 cigarette smoking variables. One was any smoking reported in the previous 30 days, and the other was a daily smoking, so if they reported smoking every single day in the past 30 days. We had an age-varying hypothesis here that the association between sensation seeking and smoking would change with age, so we used a time-varying effect model. This flexibly estimates how the association between a predictor, so sensation seeking in this case, and an outcome, which was cigarette smoking, differs as a function of time. So what it does is it estimates a function that represents the regression coefficient between sensation seeking and smoking across continuous time, which in our case is age in months. And just to kind of give you a little more info on that, this is kind of our traditional linear regression model where you have an intercept term, and then you have a coefficient for sensation seeking. If you wanted to look at how sensation seeking and smoking, the association changed across age, you would add some age terms, quadratic age, cubic age, you would interact those in sensation seeking. It quickly becomes kind of burdensome and clumsy and difficult to interpret. Whereas here, with the time-varying effects model, this coefficient is now a function showing how sensation seeking's association with cigarette smoking changes across age. So based on that, what we found is that the association between sensation seeking and daily smoking was greatest during adolescence, and I'm just going to walk you through how to interpret this graph. So here you have age in years on the x-axis, going from about 13 to 34, and then you have an odds ratio here. I've drawn a black line at an odds ratio of 1. This is showing the association between sensation seeking and daily cigarette smoking across age, this blue line, and these are 95% confidence intervals. If this confidence interval contains this line of 1, it means that the association is no longer significant. So the association between sensation seeking and daily cigarette smoking is not significant for most of young adulthood. It becomes sort of significant. It becomes significant again at around age 29 to 33, but it's nowhere near the same strength as it is during adolescence. You'll notice also that the confidence intervals are pretty big at the ends, and that's because of the density of data that was available there. But in general, what we're finding is that the association between sensation seeking and smoking is strongest during adolescence relative to young adulthood. Yeah.
Why might it go up again at like age 30?
I'm not entirely sure. What I did was, to kind of get at that, is I looked at people who went straight into the workforce versus those who went into college and things like that. And so people who went straight into the workforce, they showed a stronger association between sensation seeking and smoking relative to the ones who went into college. So I'm wondering if these are the people who are now leaving college and going into the workforce and are in environments where something like substance use would be more of a kind of intense experience, where it's like less normative. But I don't have an answer to that. I think that might be what is going on. Yeah.
How about habit and addiction? Whether this plays a role here in like conflating the cessation seeking finding you have.
The addiction?
Yeah.
Yeah, so I think that's going to get at this. I think the processes here are going to be less in line with just seeking out a novel and exciting sensation, and they're going to be more driven by the fact that if you're smoking during this period, you've probably been smoking for a while, you may be experiencing addiction, and so this may be processes beyond sensation seeking and more in line with the need to smoke that is driving this association. But it's still saying that this period here is getting at sensation seeking, whereas this association is no longer significant, probably because of addiction processes. And one way that we kind of got at that, we also looked at the association between impulse control and cigarette smoking across adolescence and young adulthood, and the association between impulse control was age invariant. It was always significant, such that if you had higher impulse control, you were less likely to be smoking. And so I think there, in young adulthood, the association between impulse control is still going to be significant, because even if it's not a sensation-seeking impulse that you're inhibiting, but an addiction one that you're inhibiting, that association will still be there.
What I meant is, yeah, but what I meant is whether you could include like a luck kind of variable in your model that perhaps can capture that effect.
Yeah, sure. So what we could do is we could maybe create another line for people who are reporting addiction and see if there's an overlap there. Yeah, that's an interesting idea, for sure. So this was for daily smoking, which is kind of an extreme behavior. We also looked at it with any smoking. So this is probably less driven by the addictive processes. And it's the association between cigarette smoking and sensation seeking is now significant throughout. But it kind of dips during this young adulthood, and it's higher during this 13 to 17 year period there. Okay, so that was the first study, and suggests that between-person differences in sensation seeking are especially important for understanding who is smoking during adolescence. But the next question now is, why is this? What are the mechanisms that are underlying this association? So these models focus on the role of self-control failures, that people don't have the cognitive capacity to inhibit these impulses to go out and smoke. So to look at this, I examined between-person differences in network neuroscience correlates of cognitive control to see if sensation seekers, there was evidence that sensation seekers had less abilities to inhibit their impulses to go out and take risks. So just to give you a little bit more background in resting state functional magnetic resonance imaging, the brain is constantly active, even at rest. You still see spontaneous fluctuations in the bold response. So this is an indirect index of neural activity. So this is just a toy figure showing you regions of the brain and their bold activity across time at rest, their spontaneous fluctuations up and down. If you correlate the time series of these regions, you end up with an adjacency matrix showing you the correlations among the time series across time. There are some regions where the time series is correlated pretty highly in stark blue, and there are some regions that have no very small correlations between the time series across time. And these patterns of, when we look at the entire brain, these patterns of strong and weak correlations across regions of the brain aren't random. They tend to, so here you have multiple regions kind of getting at the entire brain. And when we look at connectivity among them, so the correlations of their time series, multiple functional networks emerge. And these networks are based on findings of dense internode connectivity. So any node in the motor network, for example, in that kind of greenish color here, those nodes will all have high connectivity with each other in their time series, but they will have very low correlations in their time series with other nodes of the network. So that's kind of how we define these functional networks. They tend to be named by the regions that they are involved in, the functions that the regions are involved in. So you can see the motor network, the auditory network, the visual network, et cetera. And at rest, it's thought to provide insight into a history of co-activation. So yeah, I think that's all I need to say on that one. But what we did was we looked at network neuroscience correlates of cognitive control. So there are three particular functional networks that are important in understanding cognitive control at rest. You have the salience network, which is involved in detecting salience events, so incentives, but also other things that might be a reason for you to change what you're doing currently. So that's one function that's involved with it. But when these nodes detect something salient, they also facilitate access to cognitive control resources by dampening the activity of the default mode network and increasing the activity of the frontoparietal network. So this frontoparietal network contains nodes that are active during tasks, so effortful cognitive control tasks. And so this network is very important for flexibly modifying your behavior, for inhibiting control. Whereas the default mode network, these nodes tend to be active at rest. So when you're not doing anything particularly effortful, when you're engaged in self-referential processes, when you're mind wandering and thinking about yourself. And so we hypothesized that stronger connectivity between the salience network and the default mode network, and between the salience network and the frontoparietal network, would be a neural index of good cognitive control. And I have some other work that I'm happy to talk about that kind of validates this a little bit. So we had 43 participants ranging from age to 10 to 26. They completed the Zuckerman sensation seeking scale. They had 5 minutes of resting state, so they were in the scanner for 5 minutes, not doing anything in particular. And we correlated the time series of the salience, default mode network, and frontoparietal networks. And we created 2 between network connectivity indices. We had the salience network and default mode network connectivity, and then salience network and frontoparietal network connectivity. We then we did a multiple regression analysis, one for each of the between network connectivity indices. And we looked at the extent to which these were associated with age, sensation seeking, sex, and then a ton of interactions among these to capture anything else. Non-significant interactions were trimmed to arrive at the final model. And what we found is the expected association with sensation seeking, where sensation seeking was associated with decreased connectivity among the salience network and the default mode network. There was a significant sex by sensation seeking interaction. This is why you're seeing a line for male and female, but the simple slopes were significant for both sexes. So as sensation seeking increases, the connectivity between the salience network and the default mode network decreases. You find the same thing for the salience network and frontoparietal networks. Same sex difference, same trend. And so this is suggesting that, at least from looking at resting state indices of cognitive control, that sensation seekers have cognitive control networks that would, and connectivity among them that we would expect to be associated with immaturities in cognitive control.
How should I interpret the differences in slopes
here? So I'm not sure. So they're significant in both cases. So as sensation seeking increases, one is like a weaker association, but it's still there. I don't want to make too much out of the sex differences since this was a sample of 45 people, right? But yeah.
Earlier, before you showed some time series plots for the when the brain's at rest. There was high volatility in the middle.
Yeah.
How do you explain that?
That was a toy example of just a simulated time series, but yeah, but so this was with static fMRI, where you consider the entire resting state region. I've been increasingly interested in looking at like sliding window analyses to capture any potential changes in the correlation among regions over time. And so I don't have that data with me here, but what's interesting there is that if you look at the time-varying nature of the interaction with the salience network and other regions of the brain, the extent to which the salience network flexibly interacts with other systems across time, so that's going to be capturing some of that volatility in the time series across 5 minutes or 10 minutes or 20 minutes, that seems to be an important indicator of cognitive control, in addition to these ones. So it's predicting cognitive control above and beyond these static connectivity estimates. And this kind of flexible engagement of this system with other systems of the brain is getting at this idea that the salience network is a core network involved in identifying salience and then recruiting the necessary resources in order to flexibly modify behavior. Yeah. But yeah, I agree there's a lot that we're missing out if we just average this 10-minute time course, for sure. Okay, so sensation seeking seems to be associated with a connectivity profile that we would expect if there were immaturities in cognitive control or difficulties in cognitive control. But what about behavior, and especially behavior that's occurring in daily life? So this is some recent work that I just did this year with Danny Bassett. So we had 167 people. They're aged 18 to 65, so we're not getting at the developmental question yet in this sample. We just got funding to take something like this to a younger sample, so we'll be able to start talking about developmental questions, but I think it will be interesting for looking at the ecological validity of these brain-based models of risk-taking. So we have 167 people. They completed a baseline survey where they reported their sensation seeking, which is a subscale of this impulsive behavior scale. And then every day for 21 days, they were emailed at 6:30 p.m. with a survey. And in that survey, we asked them a ton of questions about their day that day. We asked them about their impulsivity that day, their emotions that day. We asked them about their alcohol use and risk-taking the previous day. We asked those questions for the previous day because if we're sending at 6:30, they might not be drinking until later that evening. And the nice thing about this type of data collection is that you then end up with 21 days of your behavior of interest. So here I'm just showing you a subset of the participants. If I put all the participants here, this would just be a block of color. So you're looking at how we measured impulsivity in daily life. We asked them this question. So there were times today that I acted on the spur of the moment. So this is the idea of lack of premeditation, this motor impulsivity, acting on impulse rather than taking time to kind of really go through and deliberate. So you can see naturalistic fluctuations over time. So this is kind of more ecologically valid than things that we might be finding in the laboratory. And it's also associated with less retrospective bias than our typical kind of previous 30-day self-reports, where kind of most colorful or most intense experience is what participants might be drawing on when they answer those questions. Here they're just asking on that day, so they're not asked to talk about 10, 12, 30 days ago. So this was our measure of impulsivity. And what we did is we took the mean of the time series for each person, which gives you a sense of their average level of impulsivity in daily life. And then we correlated with that with sensation seeking, and you can see that people who are higher in sensation seeking tend to report greater average impulsivity in the course of everyday life. So it seems to be reflected in behavior as well as the neural correlates that we saw earlier. And then the next question was, well, is this daily impulsivity important for understanding risk-taking? So what we did is when you have a time series like this, you have kind of two sources of information that are conflated. You have the between-person association, which is more in line with questions such as, do people with higher than average impulsivity relative to other people in your sample show higher than average levels of risky behavior? And this would be data where you just take the average of their time series. But then we have within-person questions, which are the kind of questions that I tend to be more interested in, which is on days when impulsivity is higher than usual for you, is your risk-taking higher than usual? And so then you're getting at the within-person associations that you try to get at in the laboratory by inducing certain conditions, right? So in terms of the between-person variable, we just take the average of each person's time series. For the within-person variable, those are deviations from an individual specific mean. So for this person in this red color, any days above this dotted line would be days of increased impulsivity. Days below it would be days of less impulsivity relative to that person's normal behavior. We take these variables, we put them in a multi-level regression. So now we have days nested in people, so we have to move to the multi-level case. I looked at alcohol use as a dependent variable. It tends to be positively skewed, so I used a Poisson regression. And at the level one, so at the level one of the multi-level model where you're looking at associations between impulsivity and alcohol use at the day level, we're predicting days alcohol use with their impulsivity that day. So whether it was a day of higher than usual, lower than usual, or just average impulsivity for them. And then at the level two of the multi-level model, which is getting at person-level associations, we're asking if people who have high usual impulsivity, so if their impulsivity was high on average across the 21 days, if these people have high usual levels of alcohol use. And then we allowed random slopes for both the intercept and the association between days impulsivity and alcohol use. So we'll get a prototypical association, but we'll also get some sense of the individual differences, and you'll see that in 1 second. So these are the results where we see that days impulsivity is associated with days alcohol use. On the x-axis here, you have days impulsivity, and it's within person centered. So these are days of usual levels of impulsivity for that person. As your impulsivity increases, your alcohol use increases. This red line is a prototypical association, and then these black lines are the random slopes to get at some individual differences across the sample. So this was with alcohol use. I also asked them a broad question about, was your risk-taking today greater than it normally is? We find the same association with impulsivity. I also asked them what was the riskiest thing they did that day, because I'm just kind of interested in what kind of risks people think they're taking in everyday life. And so that's kind of in the pipeline. I'm excited to explore that a little bit more. But for now, what this study showed is that sensation seeking is associated with decreased connectivity between the salience network and both the default mode network and the frontoparietal networks. Sensation seeking is also associated with levels of impulsivity in day-to-day life. And that impulsivity is meaningfully associated with alcohol use in our day-to-day lives. So it seems to be getting at this, are these mechanisms ecologically valid? So it suggests that sensation seeking may be associated with difficulties in impulse control, and that this could be a plausible pathway to risk-taking. For the last study, I wanted to think beyond this idea of self-control failure. When we make models like this, it often seems like we're pitting the socio-emotional and incentive processing system against this cognitive control system, but of course they work together. And so I wanted to think about how engagement in risky behaviors might be based on deliberation and a choice to engage in risky behaviors rather than just an impulse. And this is especially important, I think, when we think about things like tobacco use and substance use during adolescence, where the engagement in these behaviors can be pretty aversive. So if you look at the qualitative literature of adolescents describing their their engagement in substance use, they often talk about it as if it's aversive, that the taste isn't nice, it doesn't make them feel good. And so the idea that it's a rewarding experience that causes them to just act impulsively and to engage it doesn't seem to jibe well with the qualitative literature. And so if you look at the qualitative literature more, you can see that 25% report secretly taking or stealing a cigarette. This doesn't sound impulsive to me. This sounds like something that takes a lot of thought and deliberation. Where are you going to find the cigarette? How are you going to steal it? And many report continuing smoking not necessarily because they like it or that they find it rewarding, but they're engaging in it in order to achieve another goal. So it's a very strategic behavior from my perspective. So to get at this, I kind of looked at the extent to which engagement in impulse controls depends on our goals and our motivations. And so one kind of example of how these two systems interact with one another could be found in the adolescent literature, so work by Chuck Geyer. He shows that even though adolescents generally have less accurate cognitive control, less accurate impulse control than adults, when you incentivize them, they actually show adult-like accuracy. So this is showing you adolescents and adults, and it's looking at their correct response rate on a cognitive control task that I'll show you later on. This is a task that's basically looking at how well you can inhibit a prepotent impulse. You have behavior in a neutral context where there's no money available for performing it correctly. And then here they were incentivized. They could earn up to $25 more if they had accurate performance on the trials. And so what you can see is that while the adolescents tend to have immature cognitive control relative to the adults in this neutral context where nothing is to be gained from engaging in cognitive control, when you reward them, they begin to look a lot like adults. And so again, this is just getting at the idea that these two systems, even though we think about them as kind of antagonistic with one another, the heightened reward sensitivity of the adolescents, so their heightened sensitivity to potential incentives, may be motivating them in this context to engage in cognitive control. And so we can think about this in a couple of ways. One is that, great, we can kind of shrink this gap between cognitive control and socio-emotional systems during adolescence by just motivating adolescents not to engage in drug use. But I also think that they're probably using this cognitive control, this incentivized cognitive control, to engage in their risky behaviors because they find it rewarding, and so they use their cognitive control system to engage in the type of strategic thinking that allows them to steal cigarettes and that allows them to inhibit their disgust towards smoking in order to reach the goal of impressing their peers, right? So for this study, I looked at whether sensation seeking moderated the effect of incentives on cognitive control, again getting at this idea that while adolescence is a normatively heightened time of reward sensitivity, that personality traits such as sensation seeking might be better, might explain a larger proportion of the variance than age would. So here we have 150 people going from age 10 to 26. They completed the Zuckerman sensation seeking scale, and then they completed an incentivized ocular motor task where they could earn up to $25. This is what the task looks like. It's a very simple task. We use it a lot in the fMRI research world because we have a good sense of the circuitry that's underlying this task. But basically in the task, they see a cue at the beginning of each trial that tells them whether they can earn a reward for this if they perform it accurately or if there's no reward available. So you have this incentivized context, you have this non-incentivized context. After they see this cue, they see a red arrow, and this is a preparatory phase where they kind of prepare to make a response. And then a saccade phase. So what happens is the screen is black, so it's very dark, and then a bright dot appears. Your impulse is to look at the dot. It's just something that everyone has. So you have to inhibit that impulse and look in the opposite direction. So if they look in the opposite direction to which the dot appears, if they were to look here, that would be a correct trial. If they looked at the dot, that would be an incorrect trial. It's very simple, which is nice. It means that children, adolescents, and adults can do it, but it's still sufficiently difficult to get at some behavioral variance. So I looked at the extent to which accuracy was associated with whether it was a reward trial versus a neutral trial. There were also loss trials, which I didn't look into, but I can talk more about those if you're interested in. They did 4 runs, so I just wanted to account for any like time effects if accuracy was increasing or decreasing across time. So this was a trial level. At the person level, I looked to see the extent to which levels of accuracy were associated with sensation seeking, age, and sex, and all these interactions. And then the extent to which the association between reward and accuracy was moderated by sensation-seeking, age, all those. And what we find is that there was no association with age, so this wasn't significant above and beyond sensation-seeking. Instead, sensation-seeking was associated with performance, such that on neutral trials, you can see this black line is people who are low in sensation-seeking, so -1 standard deviation on the scale. These are people with average sensation-seeking. These are people with above-average sensation-seeking. No huge differences here, but when you move to the reward context, so onto trials where reward was available, you can see that it's only the people who are like high in sensation-seeking or average on sensation-seeking who are increasing their cognitive control when they're incentivized. So the people who are don't have this reward sensitivity, they're just not sensitive to that incentive context. Yeah. So kind of similar picture to what you're getting in the adolescent literature, where sensation seekers may have immaturities in cognitive control, but they can recruit cognitive control if they want to. And so when we look at variability and impulse control in daily life, so this is the same data that you saw earlier, where you have impulsivity across 21 days. And I just asked a simple question of, do sensation seekers have more marked fluctuations in their impulsivity, which may be capturing this differential motivation to engage in impulse control across contexts, but now in daily life, so we're getting at a little more ecological validity. To do this, instead of looking at the mean, I'm now looking at the standard deviation of these time series. And so this person in red has a larger standard deviation, indicative of greater fluctuations in their impulsivity relative to this line in blue. And I take this as a between-person variable, and I correlate it with sensation-seeking. And you can see that people who are higher in sensation-seeking have greater variability in their impulsivity. So kind of mirroring what we find in the laboratory. In a regression model where we're also controlling for average levels of impulsivity, this association is still significant, just in case you're thinking about that. Okay. So from this study, we can suggest that sensation-seeking, it moderated the effect of reward on the antipsychotic accuracy, showing that sensation seekers have the capacity for accurate cognitive control when they're motivated. Again, kind of showing that instead of thinking about these two systems as antagonistic, that there are some meaningful interactions among these systems that we need to get at. And suggesting that sensation seekers might recruit cognitive control to obtain rewards of value to them. And I'm suggesting that this could be the case for risks in daily life. And kind of mirroring the laboratory, we see that sensation seekers show greater variability in impulse control in the course of their daily lives. All right, so to kind of give an overall conclusion, sensation seekers have a tendency to engage in risk behaviors, especially during adolescence, at least for cigarette smoking, as we saw earlier. They show a resting state connectivity profile that's consistent with limitations in cognitive control. And in the course of daily life, they show higher and more variable levels of impulsivity. We also saw that impulse control variation at the within-person level is meaningfully associated with alcohol use in daily life. And that sensation seekers, although they may have these limitations in cognitive control, they have the capacity for accurate impulse control. And I think I'll just stop there, and we can chat a little bit, I guess. We have plenty of time.
In the ad health data, did you do, you said that you had longitudinal data, right?
Yeah.
So were you able to run fixed effects models on, to see, or maybe explaining that U-shaped curve?
I didn't. So what I did was I accounted for the repeated measures by using robust standard errors, because the focus was on, is there an age-varying association? My
concern is that there might be an observed heterogeneity with these people, but you said you have longitudinal measures. These surveys are administered every year.
There are at least 3 waves of data. Not everyone has all 3 waves, but so you could start to get at some associations there.
Yeah, I think in that data you don't have a long panel. Like you're not going to see the same person at like 16, 25, and 30.
Yeah.
Maybe see them like 2 years in a row.
Yeah.
Like you don't have really the power to do like that would be really a good idea, but I don't think the data allows it to do it.
Yeah, and so that's kind of why I was interested in moving to the daily work, which is more of what I tend to do now, because when you're looking at that level of analysis, these large-scale surveys, it's like there could be so many intervening variables between that sensation seeking and cigarette smoking.
Right.
To me, when you see associations of like impulsivity changing from day to day at the same time scale as the alcohol use, so the time scale that you think your behavior is changing at, I think you're getting more at potential mechanisms than this broad personality trait. At least that's kind of why I'm more interested in the daily stuff right now. Yeah.
I was wondering whether this cessation seeking also has anything to say about how the person values his peers. In other words, are the peer effects time are related to this? Could the peer effects be related to this cessation seeking? And if that's the case, then it might be the case that there is some observed heterogeneity related to peer effects.
Yeah. I don't have data on that, but just based on the literature, we know that especially during adolescence, they show this heightened sensitivity to monetary incentives, but even to a greater extent to social incentives, so the getting at the extent to which they want their peers to like them and things like that. They're both tend to be underserved by the same neural circuitry, like regardless of the type of reward. So given that sensation seekers have this higher response in ventral striatal areas to monetary incentives, I wouldn't be surprised if they were also had a greater response to peer rewards of some type. I don't have data on that yet, so I can't tell you. With the daily data that we collected, we also collected social network data. So for every person in our data, we have whether the individual where they think their peers are in terms of their levels of sensation seeking and the extent to which they engage in risk taking and substance use. So we might be able to get at some moderating effects there to see if people who are high in sensation seeking select themselves into peer groups, for example. I think that's kind of what you're getting at. That might be driving that association with risk taking.
Yeah, I think there are studies that show that teenagers will basically, if they're by themselves, they won't do risky things, but once you put them in front of other teenagers, of course they act like idiots.
Yeah, there's some
like,
great
especially
work.
Guys, but
Yeah, there's some great work by Jason Chine and Larry Steinberg at Temple University and many others now that show exactly that. Like adolescents look adult-like in the lab most of the time, but you do something simple like you don't even have to ask the peer to tell them to engage in risk taking. You just let the adolescent know that they're in the room or they're watching what they're doing, and all of a sudden you see this like context-dependent change in risk taking. And so again, that's another reason why I like going to the daily life context, because I'm like, that's where it's all happening, right?
And what are the determinants of sensation seeking? Is something like that just genetic, or is it something like environment?
I mean, for me, I always think that genetics and environment go hand in hand, but I see them as playing out in the brain. And so when we look at the brains of sensation seekers, they tend to have this exaggerated dopaminergic response in the ventral striatum. So that's like a kind of neural characteristic of people who are high in sensation seeking. What it is that leads to that, I don't know. So there are certain things that are known to affect the activity of the dopaminergic system, including things in like very early childhood, like hypoxia, even during pregnancy, kind of tends to lead to changes in the dopaminergic system that are meaningfully associated with things that we would expect to find in sensation seekers. And yeah, I don't know if there's good research out there yet to know exactly what leads some people to be high sensation seekers versus not, but I would be looking at that circuitry to figure that out, I think. Yeah. And so kind of in line with that too, one of the reasons I also looked at monetary incentives and their ability to increase cognitive control in the sensation seekers is that we know that they tend to have heightened reward sensitivity, but it tends to be in response to really extreme rewards. So I just wanted to be able to see if will something as mundane as money motivate them as well as the kind of more exaggerated risks that they tend to like.
Do you think you'll look into competing incentives at all? Like maybe social pressure versus money, if that could
Yeah, I mean, that's a great question. I mean, because that's kind of what interventions are doing, right? You have the incentive to engage in cigarette smoking, for example, and in continuously management interventions with people who are addicted, you ask them, is the money going to be enough to compete with this desire to smoke, right? If you stop smoking, I'll give you money, but that might not be strong enough. I don't know if so I actually do have some data on that that I can show you. This is in people who are addicted to smoking. These are daily smokers. And they did an incentivized cognitive control task, and they did it twice. One when they were smoking as usual, and one when they were abstinent. And when they're smoking as usual, you can incentivize them with money to have higher cognitive control. They do better. They're more accurate on cognitive control tasks in the reward condition relative to the neutral condition. Again, this was like they were working for like $5. But when they were abstinent, there was no significant difference between the reward and neutral condition, which we think is because there are changes to the dopaminergic system that happen as a result of smoking, such that when you're smoking as usual, you look a lot like someone who's not addicted. But once you get rid of that nicotine, changes that have happened to the dopaminergic system that kind of lead to this like reward insensitivity, especially to non-drug rewards, start to become unmasked. And so this was just after 12 hours of abstinence, and money is no longer rewarding to them, right?
Yeah, what if you reward them with a cigarette?
Yeah, and then people like that. Yeah, that they would definitely work harder for a cigarette than money. And so this, I think, is kind of interesting. I didn't really talk about this, but it's interesting work when you think about what contingency management interventions are doing. They're putting smokers into this abstinent state, and they're trying to motivate them with money, but we know that money is not motivating them that much at this point.
What data set was this?
This was a laboratory data set that I collected as a PhD student. It's not a big one. It's like 18 daily smokers. And yeah, it was just collected at Penn State in the lab. Okay. Good.
How about negative reward? What I mean is
Like
cost.
punishment.
Cost. Not necessarily
Or cost.
punishment.
Yeah.
Suppose, I mean, having a smoker smoking in an extremely cold environment like here, outside, is very different from being able to smoke in a nice environment like in Florida, right? So, if you pose some cost on them.
Gotcha.
Okay.
Yeah.
Do you see the responses are the same? I don't expect that. Is there a symmetry, in other words?
I don't have data on that. The closest thing to that would be there's some work looking at whether sensation seekers respond to the potential for loss, or like loss of, like, if you perform this incorrectly, you would lose money, right? That's kind of the cost that they're looking at. There's some evidence out there that sensation seekers are less sensitive to that that potential for losing if they do something. But I would still say it's preliminary. I'm not confident that we know that for sure yet. Yeah. And then in terms of the symmetry, I guess loss tends to be, the magnitude tends to be about half as much as a gain, and you see similar levels of motivation there.
More questions. Thank you so much for joining us.
Yeah, thanks for having me. It was fun.
Thank you.
Cool.